You read somewhere that me and you and everything are moving through space-time at the speed of light. Is that true? Yes, but also no, and also welcome to the world of science pedantry when it comes to definitions. Problem number one, the definition of space-time. This is using space-time in a different way that space-time is used normally, and physicists use both interchangeably, and I hate it, and physicists hate it. So space is space-time. The three-dimensional world we live in is space-time. When you get close to a huge mass, you warp. Space-time. You can't really take time out of the equation. Space and time are kind of the same thing. That is kind of a, for lack of a better term, locational definition. Like, it really isn't because everything's in motion, but it describes, like, the fabric of what we are all living in. The fabric of space-time. What you have read and linked me to a video of is a description of space-time as a numerical relationship in motion. It's relating our motion through space and our motion through time. And yes, you could call that space-time, but again, now you're calling two different things space-time. And while, yes, at a high enough level, you could say motion and location are kind of the same thing because motion is relative, you are essentially shifting the vantage point as you talk about these concepts, and that could get really confusing, and so that's why it's frustrating. Number two, let's talk about the meat of what you read about. You can plot space and time on a graph. You can place them as coordinates, x-axis, y-axis, z-axis, t-axis. And making things very simple, when you plot something's speed on that graph, it is all the same. If you are not moving, then you have to experience time as fast as possible. And if you move faster, time slows down. I covered this in another video. And that relationship is constant. That's what people mean when they say we move through space-time at the speed of light. But also, light moves through space-time at the speed of us. Everything moves through space-time at that constant relation. And the reason why I hate using the terminology, we move through space-time at the speed of light, is because that inevitably makes someone go, aha, we can move the speed of light, and that means we'll surpass it someday. And I have to go, no, we're just describing a relation that everything, literally everything in space-time moves at. In fact, it's kind of a misnomer to call it speed, because speed is the time rate that an object follows along a path. But we're already mapping out time as another dimension in this scenario. So it's more accurate to say the scalar value of everything's motion through space-time is the same. But it's also important to note its vector value, its velocity, is different. But that could be explained in another video. So yeah, it's not that we're moving at the speed of light is moving at the speed of us, and in that map, everything is moving at the speed of everything.